Interesting, interesting. Doesn't load at all. Interesting. Oh, there you go. There you go. There you go. Okay. All right. We'll get started. 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 Yes, that's the example input. Do that in there for now. I need some tea. Alright. Usually the bold words are the ones that are interesting. Okay, so the sentence is the first one. So many reports, one report per line. Each report, so that's a report. Oops, that's a report. Each report is a list of numbers called levels. Okay. All right. The example data contains 6 reports in, wait, yes, 5 level each. Okay. The level with either all increasing or all decreasing. And 2 levels. All right, that's pretty straightforward. So we first need to make sure that we, for each row or each report, we execute it. Each one, now we get actually numbers. Let me see the input. That's the production input. My tool downloaded. No negative numbers. Okay, that's good. No negative numbers. Good. All right, but could be different number of rows. That's fine. So we'll call it n. No, we'll go like this. And assign each of these. And then we display as the first of n. All right, so all right. So sort. We want to see if sorted is the same thing as, right? Sorted is the same, all increasing or all decreasing, right? Okay, so let's check if it's all increasing. And just to double check, any one of them is true. If both, right, it has to be both increasing. So this one is decreasing, and level is the difference between the two levels. Any two levels is with two adjacent levels is at least 1 and at most 3. Okay, so no zeros and no choose. No, at least 1 and at most 3. Yeah, so it can be repeating. All right, so that will help with the sorting, because it doesn't matter if it's stable sort anymore or not, because if it has repeated numbers, it will fail the next condition. All right, so this, I think we might be able to do it tacitly. So we do sorted. Right. That's dumb. Okay, so for the first row, we'll do it for each row, actually. First row, right, because we need to figure out how many are safe. First row, we sorted, but again, we only get numbers. Why do we need to sort it? We don't need to sort it. We just need to check if each one is, yeah, okay, there you go. Yeah, we need to compare the two, right? And here, so this one is the difference, right? There you go. And the difference between the two. Oh, we only need the difference between each two. Right? Yeah. Okay, so here's my plan. We compute the difference between each two adjacent levels. And that will tell us, that way we can figure out if it's increasing, because that will tell us what the numbers are. And if, or decreasing, right? Yeah. Okay, that should do it. Okay. So for each one, we'll do, so we don't need to do this for, so for all the input, for each row in the input, we'll run 2 minus reduction, right? And I think we need unique, right? I think unique, because that will tell us like if it's all just ones or twos, right? There you go. Doesn't work. Right. Of course not. Okay. So the first one, for example, has increases of 1 and 2, and that's safe. So if it's 1 and 2, that's safe. If it's -1 and -2, that means it's decreasing, and always, and also safe, right? Because of the second condition, which is adjacency levels, right? If there's anything else, like both ones and negative ones, or fours, or anything. Oh, 3 is allowed, right? 3 is allowed, right? To adjacency at least 1 and at most 3. Okay, so if it's 1 to 3 only, or yeah, okay. All right, so we need to check. So that's for part 1, right? I don't know. We'll do the differences, and then we'll check if it's only 1 and 2. We'll do that. 1 to 3, sorry. We need 1 to 3 only. Okay, let's try it with the first one. It's a little slow at the moment. So the first one is 1, 2, right? Can we check if it's 1, 2, 3? Yeah. I can do it for all of them, right? So only. Yeah, the last one is also safe because it's negative 1, 2, 3. Oh, we can actually make it absolute at this point because we don't. No, 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 no. We can't. We can't do that. All right. All right. No worries. No worries. So we can. Let's try one at a time. So we want to check if there are any. This we need to check that it's only 1 and 2, right? Yeah. We can do and and or equal 1 and 2 and 3. Would that work? No, it's not. Only the dot product. Yeah. What if no intersect? Wow, why can't I do this? We need to check that the values are 1, 2, and 3. No more, no less. Could be less, but no more. So it could be 1, could be 2, could be 3 to 1. Doesn't matter the order. Doesn't matter the order. Could be 2, 1. I think we do need to do a dot product, right? So we'll give us here. Okay, we'll do dot product. 1, 2, 3. So here we have a 1. So we don't want. No, I still need each here, do I? Okay. Okay. Or okay, I'm a little slow here, so we're gonna do a test table, right? So we need a function that works for 1, 2, and 3, 3 to 1, right? These will end 1 and 2, 1 and 3, right? 3, 1, right? That will also work. But if I have 1, 2, 3, 4, or I don't know, 0, 5, whatever, that will not work. So let's check it here. Okay. Each. Yeah, so that method doesn't work. Maybe it's like this. Ones. Okay, I think this is the way. Okay, yeah, there you go. That works. Only the first one works. But we need to do either this one, don't need display, either this one or exactly the same thing. So let's call it check, and it takes W, and this will be alpha. That way we can call it 1, 2, 3 jot, because to each will not work. As a check, right? But we also need -1, -2, -3. Yeah. All right. Okay. 1, 2, 3, and then -1, -2, -3, and I think that will work. There you go. Yeah, and so that will check for each one of 1 to 3, and for each one of -1 to 3, we'll run it on our input, which has been pre-processed to be only the differences, unique differences, and we need to combine with an OR. Nope, wrong way. Yeah, and then sum up all the ones. So that's that, and let's run it for real input 663. Yeah, all right. Moving on to part 2. All right, part 2 now. Editor, okay. Okay. Interesting. More checking. Engineers are surprised by a low number of safe reports until they realize I forgot to tell you about the problem dampener. All right. Problem dampener is a reactor-mounted module that lets you react safely. That lets the reactor safety systems tolerate a single bad level. All right. Okay. Same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts as safe. If removing a single level from an unsafe report would make it safe, then it's safe. Okay. Interesting. All right. So more levels will be safe because, I mean, existing safe levels will already be safe because they're safe. But here we can remove a 3 and then automatically it's safe, but only once, one removal. Okay, so our difference thing doesn't make sense anymore. Maybe without a unique, it might work. I think in our input we didn't even need unique. Yeah, we don't need it. Which means no. Okay, so here's what I was thinking. Can we still only use the intermediate differences, right? And then effectively we're trying to merge things away. So if it's sorted, but there's, I don't know, let's look at this first input, right? So it was still it was unsafe before, now it's safe because if we remove a 3, it is now, what was the reason for it not being, yeah, because it went up and down, right? Whereas so if we remove 3, then it becomes just up and it's all fine. With this one, the problem was that 4 is neither an increasing or decrease, an increase or decrease. right, it's the same one, right, same. Here apparently we cannot do anything right because it's already sorted. If it's already sorted, and there's a big jump, then it doesn't matter. If you remove more elements, it will make the jumps even bigger. Okay. But if we have a repeated digit, so repeated digits can be effectively fixed, right? But okay. My thinking is if we go up and down, all right, let's take a look. Go back to the example input. Still process our input like we did before, right? These are the differences. So first and last are fine. We don't worry about those. We want to look at the second last. So that one's fixed because it's a 0. Okay, so now we're basically saying 0 is allowed, but only one. Only one 0 is allowed. Or 1 0 is allowed. Yeah, okay, that's fine. With this one, the problem was that it was all decreasing, but here we went between the two. Yeah, there's one going up. Okay, but the problem is now if we remove a 3, it becomes difference. No, which one do we remove here? Yeah, 3. Maybe I'm missing something. Okay, if we remove 3. No, hold on. This is a different input? No, same input. Okay, hold on. Let me just make it more saner. This one, right? This is the actual difference. The actual difference is we go up 2. We go up 2 from 1 to 3. Then we go negative -2 from 3 to 2. Then it's back to 2 again, up, and then 1 additional 1 at the end from 4 to 5. If we remove a 3, I mean, the simplest way is just to try to remove each one and see if it's safe. Should they do it like that? That sounds hacky, but I don't know. Let me do it that way, that I can optimize. Because I think that should be pretty simple. So we want to generate. Is it gonna be slow? We have txt. No, we have 1,000. That's nothing. That's nothing. Okay. So given an input, let's say we have Yura. I don't know. Whatever. Doesn't matter. This one, first of n. Yeah. Let me just stop showing this one. Stop showing this one. Backtracking, interesting. Okay, some people are doing backtracking. Okay, but we're just doing it simple, trying everything until it works. Okay. Try everything until it works. Yeah, okay. So I need to generate either each of W we want to remove a W. I think we can just do it like this. We'll case it each. There you go. We print W and then omega, right? So without 6, it's 4, 6, 4, 2, 1. Without 6, it's 7, 4, 2, 1. All right, that checks out. So we got rid of every single one. And then we do a check. So actually check would be that whole thing. Let's do the 0, 1, 2, 0, 1, 2. No, 3. What's happening here? Hold up. Right. That's an array of things. And we do a check against 1, 2, 3. Right. We also still need to process each like this. Right. And then we check if any of them are working. Yeah. So there's one at least that's working. Actually, shouldn't work. It should work. Why is it not working for the 4? We're removing one number and none of them are safe. Something's fishy. Take the fourth, 0 to 0, 2, 3, 4. Yes, fourth. And checking 2, 3. Wait, right, we're doing the differences. So that's a 6 for at least one of them should be. Oh, that's why, because we can't do a removal, because it removes all of the numbers. No, that's not gonna work. I found a nice way to do it. Okay. All right. So again, back to actually removing a number. All right, iota shape of omega. Yeah, that gives us that, and we do a iota outer product with itself. Yeah, and if we flip it around, that gives us that type of matrix. Okay, and then if you flip it or split it, we get matrices where, arrays, selection indices, where we can remove just one number, right? So we take a W input and we select from each. Oh my goodness, will that work? Yeah, okay. And then we can do this whole checking business. We need the whole thing here. Okay, and we check if it's any of them are true. And let me check if this works for all of them. Okay, it works for all of them. This is way longer, but it works. Okay. Right, sum. Let's check if that works. That's it. We got it. Okay. Okay, let's clean this up. First of all, yeah, it's fast. 200 milliseconds, 170. This is nothing. It takes in the interpreter like what, 100 milliseconds, about 70 maybe, just to get started. So it's fast. I'm taking the whole input and we're trying all the different options. This is just a dumb way. Now, which part of the operation is actually repeating? It sounds like it's this whole thing gets repeated. Yeah, at least this one, right? Let me just go back to the example input. 2, 4. Just gonna get rid of pluses because they don't matter. We'll add them later. And I'm gonna see if I can. It sounds like running check. We always run check on. First of all, we always run check on these numbers. So that's right away should just be tied with it. Like that. I don't know, that looks ugly. We can make it simpler. We can just take this W, and there's a function. It's a function that computes the differences, then does this function that we did before that used to be called check. That does a dot product for, outer product for each of the inputs that we get, and for each of the 1 to 3 and negative 1 to 3, and we wanted to do a OR here as well. There you go. So I think running it on check, well, yes, this will not work because this part is already done by check. Okay. Yeah, so the first one is just run a check on the whole input because the check already runs each. And then for the second part, we do this whole business of splitting and blah blah blah, and we need an additional OR here. All right, that's kind of up there. All right. The defunds function, the defunds import is really, really good. There's so many different functions there. I always have it included, but we didn't need it. I used display from it in the beginning, but that's about it. Okay. Let's double check again that this works. I think, yep, it works. All right. Sweet. I don't know. Not the best. Doing brute force. But if it works, it works. I'm sure there's a better way to do it. So I heard somebody's doing backtracking. Interesting. They did it in prologue, so that's not backtracking. There is important, whereas for us, not so much. That doesn't fit. What else? Let's see who else is streaming right now. Let's see. Okay, there's one basher. Let's see who else is streaming. One in Scala. Bash I already mentioned. Where am I? I'm not on a list. Interesting. Cannot find myself in the list of stream. Am I streaming? Have I been streaming all this time? What? Yeah, I'm streaming. What am I streaming? Twitch, yeah. Interesting. How come I'm not on the list? Am I in the wrong section? Southern Game Development. Yeah, that's where I'm looking. APL. There you go. Okay, I'm on the list. Why am I not even showing up? What the hell? Is it because I'm in the same IP or whatever? Viewers low to high. Oh, there they are. Okay. Okay, they just don't even show people with like one viewer, which is me. Oh my goodness, there's so much spam. Holy shit. Okay, there you go. There I am. There I am. Wow. Wowza. Wowza. Okay. All right. So that's that. Let's see what else is there. Let's check Reddit for Reddit admin code. Let's see what's interesting here. Day2 solutions. Yeah, is the side down? Yes. Okay. There was a bit of delay. Let's see how much of a delay it caused for people. Day2, the fastest was still 1 minute 40 seconds. So it's not that bad. It's not that bad. Okay. Anonymous. I don't know anyone here. Let me see if I okay. Can't find Zyma. Alright. That's fine. Which one am I? Probably some personal times. Yeah. Okay. Yeah, we're taking it easy. Score 0. Right. Well, obviously we're not 100. Yeah, who cares? Oh yeah, 6,000. That was, yeah, for the first part, and 5,000 for the second part. Interesting. Because everyone started doing the backtracking and other stuff. Okay. Yesterday was 4,000-ish. Alright. Okay, that one's me. Back to the list. 23 hours, 15 minutes to go to the next one, but I wanted to see some cool pictures from or memes. I guess it's a little early for the memes. This is for the Day2. Yeah, lost 30 seconds on 500 error, side big down. Didn't read the question right, and had 5 wrongs. So that gives you that doesn't give you 5 minutes delay. That gives you way more than 5 minutes delay. 5 wrong answers delays you a lot more. Trying them this year. Couldn't exit. Okay, all right. That's silly. What else? Just me receiving. Okay, this could be interesting. Oh yeah, it's just a question. People trying to place? Oh, to get on the leaderboard? Okay. Yeah. All right. All right. Let's look at some solutions, some interesting ones maybe. PHP. Okay, I can't read that one-liner, so no. Let's look for best, whatever that means. Oh, this guy was 500th. Right. Safe will do a different. Oh yeah, there we go. Pairwise difference. Yeah, and do a difference. Okay, and then we want to return. Oh, okay, we want to return For diffs in D, either they're all big, positive, more than 0, and the length has to be 1, or they're all... okay. So this will check if it's in the positive. Yeah, I think I was thinking somewhat in that direction, but no, this is not the same, obviously. D more than 0, so they're all increasing. Now hold up, how would that work? What about decreasing? If the difference is positive, and unless he does like reverse or something. No, part 1, all he does is parse input and map safe on each and sums. By the way, in part 2, it's the same thing. We parse input, do the lax safe check, which I think that's the one we're doing. Map and sum. Why is this working? So we do pairwise diff. Hold up, what's the input again? What's the check again? All decreasing or all increasing or all decreasing, and at least 1 and at most 3. Yeah, well, hold up. If it's all increasing, then this is true, and this is 1. Hold up, this is wrong. We do the difference. Oh, this is signature. Yeah. Signature. Yeah, okay. So for that, I see now, okay. So our mini check function could have been a little bit simpler. I mean, honestly, it's not even that bad right now, right? Well, this whole thing is our inner check function, right? Where we check that, we check it against 1, 2, 3, and it has to be... can we do better? I wonder. So what if this check function was, don't need this anymore, and we don't need this anymore, so we get a difference, and those differences, they have to be, well, let's say 1, 2, 3. We still do 1, 2, 3, right? Because that's an absolute W. So the absolute values in W are 1, 2, 3. We do an OR. We don't double... hold up. If we have an input, let's say 0, 1, 2, 3, 4 belong to 1, 2, 3. Right, we could just do it like that, right? We need all of them to be true, right? So ignore these two. So that's false. If I remove 0, that's still false because we have a 4 here. Now it's 1. I put another 3 in there, that's fine. But if I put another 0 in there, that fails. I get rid of 2. Yeah, okay. All right. Yeah. So our check function could have been they exist in, absolute values exist in 1 to 3, and we don't need this anymore, and length of uniques, length of unique is 1. No, not unique, signs. So signs will give us an array of like zeros, ones, or negative ones. And so that sign, we count how many signs unique, still need to do unique, sign unique length is 1. So that should work as well. And that work? Get rid of this. Right, this has to be also each. Right, but now we're just doing the same function, so we can assign this to differences. Right, and then differences here. I forgot to make sure that they're all ones, right? And well, let's first. That can be right. It's not working properly, is it? Do the difference of 2, then make it absolute, assign it to D and make it absolute. And we check that 1 to 3 belong in those. Sure. And they have to all be, there you go. What did I have before? Okay, boy. And then let's check also that D signs, only signs, unique length equal 1. Yeah. Right, it's not or with this. Okay, so did an or here, doy, and I forgot to reduce. Okay. And by that logic, this would also work correctly, right? Yeah, that checks out. Okay, so that's way shorter. I like this one. Yeah. So we need to check if it's only one direction, right? That this effectively checks that it's one direction. Oh, I know how we can make it a little shorter. So we flip around. This part is the one that we do first here, and this part is the one that we do later. And now, doesn't really help. No, it doesn't help. Never mind. Never mind, because we need to do the sign. Okay. Right. 3 more minutes till I have to finish the stream. No chat, sorry, that's fine, that's fine. today is also a test of bandwidth. See if it works okay. What else is streaming here? Let's take a look. There's a guy making a language. Lead code. Okay, the bash, element of bash is still going on. And if I had any viewers, I would raid them. But I don't have any viewers, so. Yeah, I got timed out for the first minute. Yeah, okay. When was this sent? I don't have the time. Okay. Either way to like get notified when there's a chat or something. Mm-hmm. Okay. And then for the second part, he just did for sequence range for I, we just remove one of each. Yeah, that's exactly if any of them are, which, yeah, any of them pass a check where we remove the thingamajig. This looks long. Is there an easier way to do this? Let me just double check, by the way, that. No. There you go. Yes, still correct. But yeah, given, I don't know, whatever input like this one, I will repeat the values. Is there an easier way? To check if is there an easy way to check to generate all of the permutations where that number doesn't exist? I still feel like getting a number, length, iota, dot other product with itself, negated, and split is the best way, but it seems long. And then we still need to take W and select from it. Well, I mean, it's not really shorter, but each case W, it's a little clearer what's going on, right? Because this is in close W, or keep saying W, it's not W. All right, time box, check, and I have to go. All right, presume any fails fast, although it's possible, doesn't matter in this problem. You mean for the for this OR, right? For the second part, or if we look at where is it? Where's my browser? There you go. This any, right? It will not fail. Well, for me, it will not. I don't know how with Python it wouldn't work. It would also have to compute the whole thing, right? Because this gets run first, and then because this creates like a list, right? And then any will run at the end, right? So I think it still doesn't short circuit, if that's a question. Yeah, short circuit is, I think, what you're talking about. But I don't think it will do it that way. Nor for me. For me as well, I have to generate the whole thing. There's no short circuiting here going on. Yeah, anyway, I wanted to fix this one. So make it, I think, a little shorter and clearer. So instead of enclosing here, I do I don't need this bracket anymore. So for each of these, because this is enclosed, so it only runs once, I do the replicate. Hopefully it works. Yeah, it still works the same way. One character shorter, but more importantly, a little cleaner, a little more clear. Okay, I'm gonna keep the shorter one for the check function, and I will commit this in a bit, but I am time boxed and I have to go. Thank you for the first commenter. You're the first to comment on my streams. But anyway, have a good, whatever it is, Monday. Bye all.